everyone. Tonight, I've introduced myself several times today, but let me introduce myself again. Today, I will have a small introduction on DAT. You don't know what that is yet. That is okay. My name is Martin Heidegger. I'm a programmer for quite a long time, 18 years-ish, and I have done, over that period of time, most of the time I have done open source work, at least privately, and for 1 year approximately now, which is far too long, and I shouldn't tell you that, but for a year I'm working now with GeoRepublic, and the project is actually 100% open source. Like, everything I do is open source, and everything I make is open source, and GeoRepublic for that is my favorite company. Like, I get to do what I want, and it's all open source, and get paid for it, which is awesome. Yeah, I'm Twitter Leichtgewicht, which is unpronounceable for most countries except Germany. On GitHub, Martin Heidegger, that's my name. Yes, it's a philosopher's name. Okay, let's go to DAT. DAT is all about data. As the name suggests, it's a horrible name. Like, it's the worst chosen name that I've ever saw of any library ever, because if you Google anything about it, like, nothing will ever come out of that. It's a particle in Dutch. So I learned a lot of Dutch words, searching for any documentation. But on the other hand, it's a good name, because it's really all about data. The name is the game. That is about storing, sending, and publishing data. So these three tasks are important to us. And when I did this with the test audience, the question was like, well, what sort of data do we talk about? We talk about files and folders. We don't talk. We can talk about both things. How do you send files? How do you send folders? Some files get really big. Zip files, database files, they tend to become really big. Some are really small. If you have a folder, the game suddenly becomes much more difficult, because you don't have to compress only one stream of data. You have to keep the metadata of it in mind. It's about big and about small data. So for one, we are trying to prepare terabyte size DATs. And for one, we have like small kinds of DATs where we just transfer sensor data. Its spectrum goes from databases. There are database systems implemented on top of that, to regular documents, text documents, or movies. So as you see, there's quite a bit of range. Some is structured, some is unstructured, some is just a stream of data that has to be dealt with it. So, and the other thing is, it's public, private, and secure data. So in that, we have mechanisms for data that is transferred privately, and we want to make sure that the data is sent and published to only one person, and that only one person can read it. But it's like yourself. You can share that data with other people, and you can share it publicly on the internet. So we're talking about all data, in short. But if I take the word data in the mouth, you might think, oh, he only talks about video streams, or he only talks about structured data. No, I'm talking about all kinds of data, and that is about all those kinds of data. And when I thought about talking about this topic, I want to approach it today from two perspectives. One is what problems are there with data perspective, and in the next I will compare that to other technologies. There are no problems with data, right? You send every day several terabytes of data to your girlfriend. Like, I mean, the sort of pictures that take terabytes of data every day, I don't want to imagine that. But that's what you do, right? You send them via mail, usually. No, you don't. There are problems with data, I think, that we have to solve in order to get better as a society. Because right now, if you deal with the internet, the average data size is a few hundred bytes, which is the size of an email, or 144 characters, which is the size of a tweet. But rarely we send data that is bigger than that between two people, or publish data that is bigger than that properly. And some of the questions that I want to ask today is, let's start with who pays for how you share the data. Like, when you have data that you want to share with another person, right? You have to set up a server. Who pays for that server? Is it you? Is it the person that sends you? Can you have a system where the person that wants the data pays for that amount? Do you need to set up a payment service on the other side? Like, that's a big question. Particularly when it becomes more popular. How much money do you want to spend to share your data with other people? Like, say you have tourism data, and that tourism data you want to share with other people because you collected it and you think this is a general purpose good. But if you have to pay several $1,000s a month in order to be able to host it online, that's not going to work. The basic system of how things work is peer-to-peer. So the more peers you add, the less load is on the original server. So you can share data with that. The other peers can read the data, and as they read, they can also become new servers. So if you have very prominent data in the internet, you can reduce your server load significantly. The next question is also very interesting. Will you provide your data forever? Like, I'm not sure how many services I shut down over the years. I'm not sure how many of the initial Twitter services or open data services you've used, but they cost time to keep alive. They cost money to keep alive. They cost money, time, effort to keep alive. And sometime, probably everyone here will be dead. Who will share your data? Like, you don't think my data is valuable. You don't think the tourism data is valuable. You don't think your medical data is valuable. You don't think the natural processing data that you made is valuable. But if anybody 100 years ago would have thought that, and nobody would write down things, then today scientists couldn't go back 100 years in time about data of how the city was built. Historical map data, for example, is very important. Some tourism data, some street analysis data, even some mails can become very important in 100 years' time, even if you've died by that point. But if you don't have archives of it, and we don't have a data service that can keep it, there is no way to provide that after you're dead. I mentioned before that in DAT, everybody can become a peer. Those peers can exist even after you shut down the original server. They will just stay alive. And every copy has the same address as the original. The address will not change. Which means that if you once share data through that, and other peers come and share that same data, they can share it long past you're gone. They can reuse the same data structure and everything that you prepared. And as long as there is one backup of that system somewhere, it will stay alive forever. Which I think is a very important thing for society to think about. That not only Google has all the data. Like, I think another company should have all the data too. Another question, and that is more in the sharing part, is how long does it take for you to upload to a server? Like, okay, you probably only upload 1 or 2 images, right? The people that I'm working with, they try to upload 500 megabytes to several gigabytes of data in one step. Like, several gigabytes means like 100 gigabytes of data. And it's kind of hard to upload 100 gigabytes in one time. And it doesn't like take 1 hour. It takes, like, depending on the internet connection, it can take between 1 and several hundred hours. And that is problematic, right? Usually they use disks. So they take a USB stick or a hard drive and send it via post, and the post takes it out and plugs it in somewhere else. And even that system is problematic because the disks break and USB sticks break and you have to do it again. It's horrible. In that, what you could do is, if you have your computer, particularly if you have the data on your mobile device, you can upload it first to a server that is close by. And because everything is uploaded in parts, which I come to later once more, both closed servers can upload to a far server. You can channel and multiply locally and then upload together with more effect, which is very important for the use case that I just mentioned. That works. Even with that question, can you stop and restart an upload? All data in that is analyzed and specified, so there is very few chance of lost data. Very few. There's 0 chance for data to be lost in the transfer. There is 0 chance for data to be corrupted by peers, and you can stop and restart the upload at any time you like. Which means, for a research person, they can start the upload process, close their computer, go home. As much as was transferred to a local peer was transferred at that time. Next time they open it up, it just continues. Like you have a very stable connection. That's when we're thinking about personal computing. But the actual approach where I use that is cars. And if a car has a hard disk and it drives through a scene where it has Wi-Fi or internet, it can transfer the data. But as soon as it goes out there, you're gone. It's out, right? So in that, since everything is blocked and since everything is shared to peers, you can reconnect and continue with uploading data to a far peer in parts. I think that's an important use case that we need. And another question is, do you have servers all around the globe? Like I mentioned before that every peer becomes a partner, that this is very useful if you have very popular data suddenly, because you don't need to share the server hosting costs. But this is actually more important if you have servers, customers all around the world. As Austrians, I have to access government data in Austria, and that sucks. Because Austria, like the Japanese government, has servers only in Austria. Japanese government has only servers in Japan. And they would not dare to publish their data outside of Japan. Even the Amazon host services that are used by the Japanese government have to be on Japanese soil. But if I have this peer-to-peer network and want to share the data far away, I just have to have one peer sitting somewhere in Europe, and all the people in Europe will suddenly get quick access. If I'm the first person to access the data in Japan, all the Austrians that need the same data could get it at the same speed. Yeah, so DAT servers are where the users are. I have 2 or 3 more slides about that topic. So one is, do you trust your services? Right now, if you want to share data, use services like Google, GitHub, Dropbox. Dropbox is very much loose, boxy. And one of the questions that comes with those services is, don't they have administrators that look into the hard disks? Like, how much of it is encrypted? What if they have a leak? What if there's a server hacking into that stuff, right? So for private data, I think the services are a bit problematic if you have them. You want to host them locally, but locally you don't have the quality. So that's a problem. The other problem is you're relying on a service that is maybe funded by investors. What if they run out of money? It's all your data, you have to rearrange again. Kind of problematic for a bigger company, kind of problematic for someone who cares about this. And I should mention this. So in that, it's solved by having as little as possible centralized systems. This no DNS, I will come back later why this is a good idea. But basically that runs without a DNS. It doesn't need SSL certificates. It doesn't need a central certification authority that you have to pay money in order for things to be secure. Things is secure by default. There's no man in the middle. There's no database server that is stored by default. You can set up things. You can make backups on things, but they don't need to be stored by default. And as such, there's no administrator in the middle, which I'd call more secure through less points of failure. And for scientists, one last point, I think. What version did you use is important. DAT, and I will come back to this a little bit later, that is a little bit like Git. So everything that you change and everything that you submit becomes a new version. That version is encrypted or hashed and verified. And as such, you can make sure, even after a long time, that you use the right version for a process. If the version can be read and the researcher can just specify the version, and because the data is archived and stored for a long time, it's just there. And because it's peer-to-peer, you get the latest version immediately in hand. So if one peer gets a new version, you get notified, so you could do application updates for this. So I have to run a bit through those things. Server costs, lifetime, transfer speed, upload stability, the global CDN. That was the trust that the version puts updates. That's one of the things that I was just talking about. That's the general concept, right? I will not try to explain it to you how that works. What I instead will do is compare it a little bit to other technology that is out there. So I will compare it to those 4, and I need to hurry a bit through it because I have 5 minutes left. Okay. So that is a little bit like Dropbox. You take a folder, you put it to Dropbox or to that, and you get a link. So this is the DAT link, this is the Dropbox link, right, where you can share. The difference here is that link, as you notice, it doesn't have any readable name, which means it doesn't have DNS used. It's a bit different from Dropbox because everything is open source. That is developed as an open project. You can look at the source code and everything on GitHub. There is a specification online. Everything is clear. There is no company between. In Dropbox, if you upload stuff, the company will hold it, and the Dropbox has to keep a copy of the data. Has to. There is no way how Dropbox works without having a copy of your data. That doesn't work with that it does. That is a little bit like BitTorrent. So in BitTorrent, you have like this torrent file that contains a lot of data. In that, all the data is inside this link. It's encrypted inside the link. So you don't need more than that link to get it, which makes it easier to use. Like if you have the torrent file, it's a bit hard to send it over a text message chat. You have to use file upload and download for that stuff, which makes that simply easier. Also, one important part is that the same DAT can contain new versions of data. And as it has new versions of data, you can have the link before the data is added. So you create the link, then you add the data. So I can send you the link before it actually contains data, which is very important. And it's not limited to peer-to-peer. So BitTorrent only works peer-to-peer, but in that we can actually have regular systems that work with HTTP that just replace this if we wish to. And another important question that I always get asked, like at the last meetup, people only came up because I mentioned blockchain. They didn't care about that, only care about blockchain. So that is a little bit like the blockchain. So it is immutable. If you delete something from a DAT folder, it will actually add data that mentions that the file was deleted. The file was actually not, it's never actually deleted, it's just marked as deleted. And the data cannot be faked by peers. So if I give the DAT data to a peer, the peer will not be able to add fake data to the end of it, which is a very important part of the blockchain. But it's also a bit different because there's no proof of work in that, which means we don't contribute to global warming by using it, which is very, very important. And as such, we have no guaranteed copy of data. In the blockchain, there will always be a copy because someone verified it at some point, and the verification of it is shared around, and the data becomes very public, which is kind of unreasonable if you want to have private data for some reason. You need to encrypt everything additionally on top. Okay, last comparison, I think. That is a little bit like Git. So if you have been to the Git Hacker News Kansai Git presentation before, every version and everything that you have in that is just a pointer to the highest version. And every change that you do, it just becomes a new version. So Git will add version of the version. And everything is critically verified by a hash. Like if you have the Git version number, it's this long hash, it's similar with that. And because of that, it is technically possible to revert to older versions of that. But the implementation does it a bit different. So first one is important. That doesn't store all old versions. It just stores the latest version. The older versions, it only keeps as an index, where it knows that there should be an older version, and the older versions have this and that name. But it doesn't actually store it on the hard disk. So when I have here a 250 gigabyte notebook, I can have 50 gigabytes of data, and if I update that, it still stays at 50 gigabytes. It doesn't like eat my whole hard disk at the time. I will skip a few points, but because it's not only focused on text data, which Git has an exclusive focus on, you can use it also for videos or key value stores, which are implemented on top of that. So let's summarize. So that is not a fictive project. I think that solves some actual problems that we have sending and sharing and publishing data. And the ones I mentioned before. That is about data distribution, where you want to make sure that your data is not just in your hands, but in other people's hands. That is about, it's an extension of current service, and it's not completely new development. It picks the right technology, in my opinion, of technologies existing to not crash the environment and burn our society to the ground. And because of that, that is about liberation, where we liberate ourselves a little bit from Google and Amazon's stronghold and try to find solutions on our own, which makes it a very important and interesting technology. Thank you very much.
So we have a bit of time for questions, so if you have any questions about that or what you can do with it, please go ahead and ask Martin.
Yes, Alvaro, please.
I think you in one screen you say you can reverse version.
You can or you can't. But did you just say you can or you can't?
I mean, are you able to return to a previous
Yes.
version?
So by default, it doesn't store it, but you can set it up so that it's stored somewhere. If there is a copy of it, for example, at the backup server or somewhere, you can revert to it. But if there's no copy, it's kind of problematic.
Yeah, because you say you don't keep the data from the previous version.
Yes.
It's like an
But if there is one peer that has a copy of it, no problem.
So you mentioned there's no DNS, so like,
Yep.
what's the current best practice for sharing links of DAT services?
So there are technically two ways. So if you have private data, of course, just take the link and share it. If you want to publish on a web page, there is something called DNS ID lookup, where you have one DAT link in your DNS hostname settings, and it will just use that if you have a link. That is currently a bit discussed, how that should be implemented in detail. It works already, so there are implementations that use this already, but there's discussion if this is a good idea, if this could be made better.
So that's kind of decentralized DNS system?
The DNS, we use the DNS system for that.
Oh, okay.
So in the DNS headers, or in the DNS settings for a domain, you would add a text file that specifies a DAT for that DNS. So you would be able to access everything under that DNS domain under a DAT link. Yes?
Can you access that through other browsers than the your browser? Or?
Right now, not. The Mozilla Foundation just gave a lot of money to the DAT Foundation to document the API and the data structure properly so they can add it to Mozilla.
But is that open source?
It is open source, it's just not as well documented as they like. So they give them data to document, basically, their work. There is also, Mozilla is written in Rust, if I remember properly, so there is right now a Rust development in process of that, which means it will be available in that, in the Firefox browser in foreseeable future.
So
Yes?
you mentioned like everything is files, if I understand correctly. So if you wanted to set up like a relational database, how would you do that?
So the relational database in itself is a bit problematic because it's more comparable to a Hadoop database or like a big append log. So you basically have a log of data. I said it's not text-based, so you can do non-text-based stuff. Where it would actually work is you put every change in a log, and then you have indexes that are updated every time the log is added, and you build the index every time. But you could, for example, have another link to the index, or wikit index.
Okay, I have questions like, how are you going to manage to, for example, if someone going to use like inappropriate way, for example, copyrights and other things, if someone going to upload movie, is it possible to manage all these things?
So copyright, you're asking for the copyright question, right? For it keeps forever. So it's a very funny question because technically it's not preventable by any technology anywhere. We can't do anything if someone publishes data that is illegal. We can't just, like what technically everybody in the internet ever has done is just we can shut down the peers that seed it. Like that's the same thing with web pages. Like if a web page seeds a video that it's not allowed to seed, the web page is shut down. And similarly, it would work with DATs. If there happens to be a peer out there that sees it, there is a request from some company to that IP address and says like, please shut down that peer. Same like with BitTorrent. That you cannot switch off BitTorrent. You can just switch off the peers that seed it.
So how would you switch off a peer of a page that visited? Visiting on the server?
So we are going from the perspective from a movie company.
Yeah.
The movie company sees that this peer seeds that data. They think, oh, this is not a good thing. It sees which peers, that there's an IP there, seeds the data, and it says a cease and desist order to that IP. If they don't know where that is, it's kind of hard. There is no way to prevent that. Yeah. But we are willing to get into that discussion.
So you mentioned also like this, you can store the data of the websites that you're visiting.
Yes.
That, right? Like, is there a limit to how much is stored on your machine, or like it basically increases as you traverse more websites?
Technically speaking, that is structured in a way that you can access things sparsely, which means if you have a big data set of millions and trillions of files, then you can access only the ones that are interesting to you. There is a system, it will be improved. The current system is suboptimal. It only allows for a limited amount of files in there because else memory overheads and these sort of things just kill any performance gains. We have a new system that is supposed to work at Wikipedia size. So we're working right now to get Wikipedia into a DAT, where you can just share the whole Wikipedia in one link and all the updates wherever, which is kind of cool. Like, I kind of like that thing.
So how can you use that links right now?
Right now,
do you need to use web browser or what? Somebody sent me that link. What have you done?
Yeah. So you can get all the information on the DAT project. There are three ways right now how we can access that, access and share that. One is a DAT CLI tool. It's a Node.js module where you can just go into the CLI and share some folder and download some folder. There is a bit of fancier version, which is called the DAT desktop, which is what I'm working on these days, which is just an Electron application that downloads that. You can just use it like that. And most interestingly, there is something called the Beaker browser, where if you share a set of data and it happens to contain a website, you can actually just browse there and just use it as a website. I have 3 presentations made for last week. Only 3. And in the last one, I actually show people how to use it. I will have a workshop on that in Osaka at some time too. Yeah. Yes?
It's not that protocol, but is it still like transmitted with like HTTP or like?
So technically, that works completely out of the HTTP thingy. It also works separate from TCP. So the base implementation technically uses, so it's somewhere between TCP and UDP. It has adapters for both, where if you have a peer that only supports TCP, it will use TCP. If it only supports UDP, basically does TCP over UDP. And so it's lower than that. It's not on the HTTP level. HTTP, as far as I remember, mostly works, no, it should work without DNS. Yeah, it works without it. So it's parallel to HTTP. HTTP, you only connect to one server. Here you connect to many, which is an interesting aspect.
How mature is that so far? Like how long is it going to take to make it the full implementation? So the features you're looking for?
So the let's put it in, like, I want to answer this in 2 parts. That you can use right now to communicate with people, but it's not production ready. The reason for this is what I mentioned before, that we are trying to fit Wikipedia into a DAT. And once we did that, I think it's proper to be used for bigger things. But that shouldn't stop you for doing some development with it right now. All of the core technology is open source, and some of the services that are built right now, like chat software or things like that, they use already the next generation technology under the hood. So you can use, there's something called a HyperDB, which is a key value store based in that already uses next level technology. It's not in the client and it's not in the CLI, but technically in the background it already works. And that can be used already for really big data sets. So it depends on the application. I wouldn't use it yet for publishing big websites, but small websites, sure, why not? There are some Twitter clones and things like that working. So.
And is it possible to set up a DAT node or peer or whatever you call it on like AWS server, for example?
Yes, no problem. No problem. The ports need to be open. Like you need to be able to connect outside of the world. Some DHCP ports needs to be available, but other than that, you can run it and it goes. There is some daemon implementation of it also that you can use as a daemon monster to share that you can just put on an AWS. There is also a web service that is called HashBase, where you can pay for a server to hold your data, like a backup server. It's also experimental, but it works. Like I use it for the workshop. Side anecdote, at the workshop, we had 60 people around attending, and we all had our computers open, and they all downloaded the same DAT, and we created new DATs during the project, and it was and during or somewhere in the middle of the presentation, I told them, yeah, so you created a few DATs now, and if you look at the data size, this was now 60 megabyte per person, a few hundred times totally. And did you notice any lag? It was always like almost instant. Like the 60 megabytes were transferred like there. So if you do workshops or something like that, it's really cool.
This could be very good for mobile networks.
Yes, mobile networks, as I mentioned. So because you lose and re-add data. Perfectly fine. Tricky, but because nobody else implemented it yet. But yeah, I think it's an interesting technology. Yes?
Is it still possible to like intercept like
that?
data transmission?
No. It sounds weird. So it is possible to de-encrypt the private. If you get there is actually 3 different keys that are used in that. What you would consider a shared key between us. If you can decrypt that, the shared key, not the key that is sent over the network, but the shared key, then you can read the data. That is a simple decryption-encryption question. Right now, the decryption-encryption is not strongly defined in that. In order for in future to upgrade it, like if there is new encryption coming, you can upgrade that too. If without that key, it's not even possible to read the data stream. Like you cannot even get the data stream properly stored. You need to keep the TCP packages somewhere in memory, and need to make sure that you don't even know which TCP packages are transmitted in which order. Like you get maybe a part of the file, but you don't know if it's the beginning or the end of the file, and the TCP stream, you don't know if there were delete messages inside, and it's really tricky to try to keep it like NASA, not like the NSA does, to keep all the TCP traffic until you can encrypt it in 10 years. And it's a bit tricky. It is as encrypted as it's possible these days, I would say.
Is it possible technically to do chat applications?
Yes. Yes. There is a chat application. There are 2 chat application implementations working right now.
So is every message a new DAT link?
No, it's an appended message. You have your own chat, the messages that are going out from your client, and it's just a list of, they don't use files, they use binary data, so it just appends to the binary data, and you share with the other people the link, and then you get the communication between it going on. So it's a bit like if you want to implement, for example, something like WhatsApp right now, you could do that.
So it's encrypted?
Yep, it's encrypted, it's stored on your device and your partner's device. Yeah, it's as safe as it gets these days.
What are the other two keys? Is it that three?
Other two cases.
Two keys is it?
Okay, there's three keys. One is the what I have to use the right words here. One is the share key, which is the key that is used in the in the network to find other peers. So this is one that everybody will see. But if you don't know it, you don't know what you're talking about. So you're like, hello, ABCD F5, and other people say, oh, I'm also ABCD F5, and they talk to each other, and when they meet each other, hello, you also that, and then they will have a handshake, and in the handshake they need to know the public key, which at the handshake the public key is actually this. It's called public key, but it's so the shared key, the public key, and the public key is this. This is the public key. So technically here is the public key. So when I do the handshake, and you don't know the public key, do you know the public key?
No.
Fuck you. Like I will not tell him any further data if he doesn't know the public key. If he knows the public key, we exchange a message, a further message, and he will tell me, yeah, okay, I know this much about that DAT. How much do you know? And so we exchange the data. But with the public key, you cannot write to the data. You cannot append to it. You need to have a private key or a secret key in order to append data to the log. If you try to append data without that key, the DAT will break. You cannot keep the communication going on, and it's just like it's like, okay, we communicated. What's that message? And you're saying like French?
Comment ça va aujourd'hui?
Yeah, fuck you. Yeah, something like that. So like it's like he tries to use his own private key, which is French, and I don't know. Like,
I would never do that.
no. But yeah, so with a private key to write, public key to be able to communicate, and a secret key to be able to find each other. These are the three keys.
All right, a last question maybe? Nope.
Does it suck?
All right, thanks, Martin.